Hello and welcome to the last presentation of today. I want to talk about intelligent content for the manufacturing industry. My name is Ulrike Parson and I'm the CEO and founder of a company called Parson, which is located in northern Germany in Hamburg. We are information architects and help people to break up their documents into smart content. We also do consulting and content strategy and support customers in introducing component content management systems and content delivery portals. And we also do some technical writing, mainly for software products. We have been an Adobe partner for a very long time and are specialized in DITA and Adobe Experience Manager Guide. Okay, let's talk about the manufacturing industry and the challenges it faces today. The first challenge is environment protection or climate protection. Manufacturers need to increase the share of energy supply that comes from renewable sources in order to reach carbon neutrality along their supply chain. They are also obliged to report on their corporate carbon footprint. There's new legislation on the way or already in place in Europe that suppliers and manufacturers need to report about the carbon footprint that they generate. And this holds true for their complete supply chain. Another big challenge is the cost of production while facing the same competitive situation in the market. Inflation has increased over the last few months, and there's a lot of pressure on the margin for manufacturers. They need to control their production costs while at the same time making sure that their supply chain functions in all situations. And especially the pandemic has increased the demands on the supply chain. And more manufacturers are changing their sub-suppliers in order to make the supply chain more resilient. Customers of manufacturers demand personalized products, so that manufacturers need to put out more product variants in order to fulfill the configuration demands of their customers. At the same time, they need to come to the market to put those products into the market in a shorter time, meaning they need to decrease the time to market for their products. Customers do no longer want to buy products on trade fairs or want to be called by sales representatives. Rather, they want to select products, learn about products, and also buy products in a digital way, in e-shopping solutions and on websites and in applications. So digital marketing becomes more and more important also for the manufacturing industry. Another big challenge is the change in the skilled the shortage of skilled labor and the change in the working force. We do see the effects of the changing population pyramid, especially in Northern America and also in Europe. There's more and more older people and fewer younger people enter the working market. So the war for talents has already begun. And when you have to fill a vacancy in your company, there's a time of 6 to 8 months now in Germany until you find a suitable person that wants to take the job and that you want to have in the job. Also, new employees, younger employees, have other expectations when it comes to their professional life. They want to have a meaningful job. They want to collaborate. They want to work in teams. And they want to work with modern tools and in a modern environment. The digitalization itself is a challenge to the manufacturing industry because their products need to become more digital. They need to become smart and interconnectable so that they can be integrated into smart factories and used for smart productions. Because software layers and software supplements to machinery is the basis for data-driven business models like pay-per-use or pay-per-production time, things like that. And it's also the basis for remote service and for predictive maintenance. All these requirements are not made easier by existing data silos with the manufacturing companies and technical debts, like companies have different ERP systems in different branches within their company, or they have other silos, like that engineering is separated from the product master data, or that the product master data are not linked to the website, for example. So all these challenges lead to specific key trends in the manufacturing industry, and I want to show you some of these and concentrate on key trends that also involve intelligent content, so that you can learn how intelligent content may support these trends. So let us first talk about what intelligent content is, how we define it. It's actually the digital transformation of documents into smaller units of information that can be viewed in different media, that can be transported to other systems, that can be used in modern applications like augmented reality and virtual reality, and that can be used by digital assistants like chatbots. That means intelligent content has specific properties, technical properties. It needs to be structured, for example, based on XML, and it needs to be format free so that it can be rendered in different media and in on different devices. Intelligent content is always modular and can be reused in different information products, but also across systems. Intelligent content is semantic, meaning it's enriched with metadata that describe where it can be used, to which product variant it belongs, to which component it belongs, which target audience is able to understand that information, or entitled to use that information. Based on these properties, intelligent content can be searched individually and can be retrieved as an individual module and can be processed in applications. If you leave all the techniques aside, intelligent content, of course, needs to be useful. Because we do no longer know where our content will pop up, we need to write content that is self-contained and that answers one question and that describes one fact, so that you don't need surrounding information to actually understand it. Because it is intelligent content, we no longer talk about publishing content, we talk about delivering content in an electronic digital way. That also means that intelligent content can come from different sources. It can be marketing content, it can be technical documentation content, or it can also be product information like technical data. And on the receiving end, you need a software that is able to process that content. So intelligent content is not intelligent per se, but becomes intelligent with applications. Okay, let's look at some trends that we see in the manufacturing industry. The first big trend is digital twins. Forbes defines digital twins as a digital copy of an actual physical asset. And such an asset can be a product, like a machine or a component. It can be a process or a complete ecosystem. And this digital copy contains a list of all the components that is contained in this asset, the services, and of course also the information that describes those products or components. A digital twin can be used for different purposes. You can use this virtual representation for simulations, for instance, so that manufacturers can try how different product configuration behaves. It can be used to be delivered with the product and collect live data from the operation of the product. Any changes that are made in the actual physical asset also need to be reflected in the digital twin. So digital twins are very useful, and they are the basis for digitalized processes, for simulations, and also for new business models like predictive maintenance, because digital twins enable manufacturers and also the companies that operate the machinery to collect data on how the machine behaves, how it reacts to different environmental conditions, how it reacts to different temperatures, operating conditions, and also how often a specific error or warning pops up. So the digital twin is not just used for developing the product, it also lives with the product during operation and contains a digital lifecycle record of the machine. And the live data that is provided by sensors and other components enables business cases like predictive maintenance. I want to show you one example of a company that uses a digital representation of the products, and this is from Kone, which is a Finnish manufacturer of elevators. And these elevators are not only used for transporting people from one story to the next, but it's also used for machinery and large devices. So they come in all different sizes and shapes. And of course, it's difficult to find all this equipment in one place, especially in the place where the technical writers are located or where the subject matter experts that do the quality assurance are located. So what Kone did is that they put their machinery, they digitalized the machinery that they created digital twin and put those in a virtual environment, in a virtual reality environment, where the technical writers that write the maintenance documentation can try out how the maintenance is done. They have the tools there, they have the technical components there. What they also have there is the content that is a database and based and comes from their CCMS, and which can be used within the virtual reality environment to actually try out the maintenance procedures. And the experts, the technicians, use the instructions to actually check the maintenance documentation. They can also leave comments with the documentation that the technical writers can use to change the content and update the content. So this is both a test environment and a communication basis. And on this slide, you can see how smart that content is because it's adapted to the environment. On the left, you see the content, how it is displayed in the virtual reality. It's shorter, it's just one step, and you can click previous and next. And on the right, you see the rendering for a manual, and there you see that the step is numbered and the 2 steps are displayed on one page. So the content is processed in different way depending on the context. Intelligent content is perfect for digital twins. Content that describes products and services needs to be part of digital twins. And because of the properties of intelligent content, it can be assembled in a digital twin of a product, perfectly matching the product configuration that is contained in the digital twin. Because our content modules are semantic, they have metadata that describe to which product variant and component they belong, so that they can be picked out of the information tool and pool and assembled into the digital twin. Any application that is working with the digital twin can use the format-free content to display it. For example, on a dashboard or in data glasses, or also on portable devices for service technicians that go through a plant, for example. Individual content modules may be replaced during the life cycle, for example, if a firmware is updated or if a part is exchanged. And you can connect the digital twin with instructions. For example, if due to a sensor alarm, a specific maintenance work needs to be done, you can find the relevant content for this maintenance task and display it to the operators. There are different industry initiatives that want to standardize digital twins. ISO is working on a digital twin framework for manufacturing that shall help manufacturers to choose the building blocks for the digital twin implementations. And the IDTA, which is an industrial consortium, is working on the so-called asset administration shell, which is the technical format for digital twins. And this shell will help manufacturers to generate digital twins that are actually interoperable, so that within a smart factory or within a plant, different digital twins can be assembled and merged. Okay, let's have a look at the second trend, which is removing silos within the companies. Currently, there are a lot of data silos within companies. You have the ERP system, you have the product information management system, you have the system that controls production, and then you have, of course, the website, the technical communication. All that are different data sets, although there is information that should actually be the same and that should come from the same source, for example, technical data. So what a lot of manufacturing companies are working on is establishing a so-called digital thread, meaning a chain of data that goes from the design and the development of the products through manufacturing, and where the data come from a single source of truth and are transported through the system so that information can be reused. And if the source of truth changes, then the information in the other systems changes as well. That also means that companies need to harmonize their product data. Right now, as I said, you have product information, for instance, in a product configurator, in an ERP system, and the product information management systems, and they are not always consistent. So what we see in our project that a lot of companies are working on harmonization, on a data cleansing of their product data. Actually, bridging those silos can be done in different ways. You can connect the silos or use integration software or API layer software to connect the silos. Typical examples of connections are between a product information management system and an ERP system like SAP. Another typical example is that you connect the information that is published on a website to the product information management system like Senshare, so that the product information is injected directly into the website. And also we see integrations between Salesforce and the documentation platform, for example. This integration can also be done using knowledge graphs, because they are able to link information that comes from different sources. Another way of integrating silos is using platform solutions, which cover several business cases and several business needs in one platform. Adobe Experience Manager is such a platform, where you can solve your business cases for marketing, for e-commerce, but also for technical documentation. I want to show you an example of how to integrate information from different silos, and this is from ZIG, which is a producer of equipment for assembly lines, and I picked an example from their safety light curtains. And this is their product finder, and you can find and filter products by these nice facets, and which probably come from a product information management system. And then once you have found the right product family, you can also see the technical data that are valid for this product. And this data probably comes from the engineering system at one point in time. And the next click brings you to the technical documentation. So this user journey is very seamless, and the users can get all the information that they need for actually purchasing the product and configure the product to their needs in one place. The second talked about knowledge graphs is from Enders & Hauser, which produces sensor and flow meters equipment, also for the manufacturing industry, and they use a knowledge graph to combine their product model with the technical documentation. So all the red dots are product variants and product properties, and these are connected to the technical documentation, which are the blue dots here on the blue nodes on the left side. So whenever they assemble a product according to a purchase order, for instance, they can assemble the documentation that fits this product automatically. This is completely driven by the product model. So intelligent content is a perfect foundation for digitalized processes, because the modular content can be transferred along the digital thread through the systems. The metadata that intelligent content carries can be used to attach content to product variants, to components, and this supports integration into other systems. It also supports content assembly based on a purchase order, on an order code, or based on a bill of material for the delivery to a specific customer. If you want to use intelligent content for digitalized processes, there are some useful standards. As a content format, DITA is a good choice because it's machine readable, format neutral, and can be processed by applications and rendered to different formats and on different devices. For the metadata, you can use IRDS, which stands for Intelligent Information Request and Delivery Standard. IRDS uses RDF for its metadata vocabulary, which is also a machine-readable metadata format. If you work with knowledge graphs and want to use ontologies, and especially industrial ontologies, you can go to the IOF, which is the Industrial Ontology Foundry, and which offers open reference ontologies for manufacturing and engineering. There's a standard for product classification that you can use to consolidate your product data, which is called eClass. And ISO is also working on a framework for modeling industrial data. This is still work in progress. As you see, it's still with a technical committee and not a published standard yet, as far as I know. Okay, we talked about shortage of skilled people and shortages in the workforce. So the third trend addresses this challenge. We have to support people in their work because we have fewer and fewer of them, and because when the older generation leaves the work market, we need to collect their knowledge and transfer the knowledge to the younger people. So that is why a lot of applications are coming up that support labor-intensive processes and that support the knowledge transfer to people. Of course, it's AR and VR for training, but also for operation. And this is done to actually skill up people within the companies. The other means, the self-help for customer, is done in order to support your customers or the customers of the manufacturers, which will reduce support efforts with the manufacturers. Remote service is another trend that also came up due to the pandemic. We don't have enough people to send them to all the production sites, so manufacturers need to find solutions to enable remote service. Information that service technicians use in order for their service tasks, and in order to need less time for a specific service task, needs to be product specific. So it is crucial that we no longer deliver service instructions which cover several product variants, but very specific information. Support for labor-intensive processes can also be done by chatbots, by digital assistants, and of course, within the production environment, robots and cobots are used. Let's have a look at some examples. Self-help for customers, which will reduce your support efforts, can also be realized in Adobe Experience Manager. This example is from a technical documentation that is a documentation of a robot, and which is part of the demo content that Adobe provides and that we generated. So this is data content, and here you see the content about the stepper motor and how to connect it to the other components of the robot. So this is normal data content that you write in AEM guides. And then you can use the asset metadata that is available in AEM to actually make the content semantic, to put metadata about the component, in this case the motor, and about the product lifecycle phase, in this case assembly, and attach it to the topic, to this piece of intelligent information. And you can use this metadata later on in a delivery, for example, in AEM sites, to generate search facets. And here you can find the search facet again, the stepper motor, and we also selected the task. And this leads to a very shortened hit list, search result list, where the third hit is already our topic about connecting the stepper motor. So the metadata enables people to quickly find the required information. So you have the complete chain from authoring through semantic information put to the module to targeted delivery in AEM sites. Another example for intelligent content for supporting people is training. Siemens, for example, uses training content and puts them in smart glasses, which are attached to a helmet. And they use it in order to train people in energy plants, for instance, remotely. So people can go on site, put on the helmet and the glasses, and make an on-site training, which is supported by augmented reality. And for consumers, we have examples from the automotive industry. This is an HMI from a Porsche, where they use augmented reality in a head-up display to show the route and some options. And this is the operator's manual from a BMW. The content, as far as I know, comes from DITA, and in the car itself, you have exactly the content that fits the car configuration, and the user can search the content, can view individual topics, can also view videos and instructions online in the HMI of the car. So intelligent content supports people in their work because it can be published to different channels, and because it carries metadata so that it can be connected to product components and product variants. It supports faceted search and personalization of content. So intelligent content is very useful also in the manufacturing industry. However, the industry is a traditional one. So if you want to embark on that journey and get from documents to intelligent content, we are here to help you. And we do have some best practices that we apply when we accompany customers on the journey to intelligent content. And the first thing is that you need to define your strategic goals and requirements for intelligent content. Where does your digitalization strategy lead to? What do you want to achieve for both internally and, for example, in order to support your service or your sales? And what do you want to achieve externally for your customers? What are your customers asking for? Are you, for instance, required to deliver a digital twin? Or do you want to integrate the documentation of your component into a larger set of documents? So this needs to be defined so that you can know in which parts you want to invest in intelligent content. A good choice is always to start where it hurts most or where you gain most. So a lot of our customers start with service. They support service technicians by giving them product-specific information, by giving them content that is displayed on handhelds, on mobile phones, or in data glasses, so that the service technicians are able to do their task in a shorter period of time. And the second good point to start is sales. Pushing sales or supporting sales with content is a good choice because good content increases the visibility of your products in the internet. It enables people to actually configure the product and purchase them online, and thus supports sales and boost your sales figures. After you have defined where to start, you need to define your content model and re-engineer your content so that you break up your documents and create smart content, modular content that is enriched with metadata. And of course, you need to define the content supply chain. Where is the source of truth? Where do you want to manage your content, and in which other systems you want to use that content? Yes, we would be happy to support you. Give us a call or scan the QR code. And if there are any questions, I will be here after the session and answer them. Thank you very much.